Hi everyone, good morning. Welcome to Gnan Cloud Garage. In this session, I'm going to talk about block storage, file storage, object storage, and its use cases. And here is the agenda. What is storage and what is the purpose of storage? And what are the storage units from lowest to biggest? And what is the average storage growing level with the real world examples? And what are the types of storage? And what are the storage interfaces among block, file, and object storages? And similarly, what are the storage scalability options among block, file, and storage? And what are the storage use cases among block, file, and object storage? So to understand the storage use cases, block, file, and object storage, we have to understand all the above concepts first. Okay, so let's start with our first question. So what is storage? It's a general question. So storage means, as we are aware, the action or the method of storing something for future use. And storage is a location where data is held available in a digital format. And data is stored on a storage device or media, which can be local storage or external storage. Like in our laptops or desktops, we have a local hard drives that is called local storage. If you have any additional data, if you want to store your personal data into the future use, we can copy into the external storage. That means it's a external hard drives. So same way, even in the organizations also, they have a server level, we have a local storage, that means direct attached storage. And for external storage, we have a multiple storage technologies, which includes network attached storage, iSCSI, internet SCSI storage, and we also have fiber channel over Ethernet storage, and we have a fiber channel storage, and we also have a software defined storages also. Software defined storages means we have virtual SAN, Nutanix AOS, and we also have a other options from VMware perspective is virtual volumes, and we can use Skeleti, Cumulо. There are plenty of software defined storage also available. Okay, but the general meaning of storage is we understand, and media which can be stored on local or external. So normally for even the mobile devices also we can use a memory cards that is also considered of some size. Example is 8 GB. And even hard drives, we have a multiple types of hard drives like SATA, SCSI, SAS. Multiple models of hard drives are available in the current market. And one example for the real-time scenario is, we can say, let's say one example is HPE 3-bar store server. This is the server we can use for a to store all our production related data. Okay. Now let's understand what is the purpose of storage. So purpose of storage also, it's a simple to store all project related application data, and applications are loaded from storage to run in memory, and application produces output or state as a result. Example, one commonly used application is Microsoft Office applications, MS Word, Microsoft PowerPoint, Excel, Microsoft Project, OneNote, and all. Not only Microsoft Office, in the real time scenarios, we have so many applications are in use, like we can use database, either Microsoft SQL, Oracle, or PostgreSQL, MongoDB, multiple types of database applications. And we also have a other applications like ERP applications, SAP, Microsoft CRM, plenty of applications all require produces some data. In order to store the data, we need a storage. And the compute memory is volatile, and when the system is shut down and the content is disappeared. So to store permanently, we must need a storage. Either it is a local storage, or we can need a network attached storage or fiber channels SAN. Okay, and to maintain application data persistent, that means permanent storage is compulsory. It's must and should we have a permanent storage in our organizations. Okay, I'm trying to give a three examples now. See, one example is HP Alletra 9000 and HP Nimble Generation 5. This is the storage model names, and it is ideally mixed legacy and virtualized environments like you can use for a either Microsoft virtualization Hyper-V, or we can use VMware virtualization vSphere, or Nutanix AHV Acropolis hypervisor, and so on. All the virtualization environment we can use these models. As storage can be shared with non-HCA, not only hyper-converged infrastructure, even you can also share it for a non-hyper-converged infrastructure applications and servers. That is importance of these two models. And along with this, we also have other models like HPE, XPN 7 and XPN 8. For extreme performance and data availability needs, it provides a 100% availability, high availability. Okay, so depends on our organization requirement, we can choose, and also it's subjected to be customer's choice and budget. Okay, and another point is, what are the storage units from lowest to biggest? So before going for a deep dive concept, we need to understand what is the current storage units are available. So let's quickly recall all the units. So byte, B, and then generally capacity binary in 8 bits. But equivalent storage data is one text. Even if you create one text file, generally it is in a bits size only. And kilobytes means short form, we call it as KB, and 1 kilobyte is 1024 bits. And in general, when you create one document, one normal Windows document, it will create the size is around KBs only. And if you start saving the data into the document, the size will increase. And megabytes means in short form MB. And one image, normally if you capture any of your mobile image, or if you take a screenshot of any of your computer screen or server screen, normally one image is equivalent, it start with a 1 MB, 2 MB, and so on. It depends on the pixels size. And gigabyte means it's a size after the MBs, we can consider the highest biggest size is GB. So gigabyte means it's equivalent to 1024 MB. And one movie file or ISO file, suppose if you want to download any of the movie from the any of the internet or any of the sites, normally one movie file, if you want to copy to your pen drive or anything, the movie file is in a GBs. And even if you want to download any software ISO files like vCenter Server ISO, or if you want to download any of the firmware ISO, HP BIOS update ISO, these are all ISO files, it will operating system ISOs. These and all the sizes, usually it comes with a GBs only, 1 GB, 2 GB, 3 GB, and so on. And terabyte, that 1 terabyte is equivalent to 1024 GB. So after the GB, the biggest units are terabytes only. If you have a 6 million PDFs in your office environment, all your office work related standard operating procedures, SOP documents, these all are any of the project related data. Usually this data is considered it's equivalent to terabyte. And petabyte means 1 petabyte equal to 1024 terabyte. Normally for production servers, not only one server, multiple servers data, it's equivalent to petabyte. And similarly hexabyte, group of organization data. Let's say our organization is not only in one location, we have multiple branches. So multiple branches means definitely data is more than petabyte, it's equivalent to, it start from exabytes. And same way zettabyte also one country level of data. If you want to calculate one country level of data, it's may equivalent to zettabyte. Suppose one region like APAC region or EMEA region or any of the other regions, it may starts with a yottabyte. So YB, the short form is YB. And brontobyte means it's a BB, most of geolocations, the entire geographical locations, any specific geos. Okay, it will consider as a brotabyte. And geo type, so geobyte means it's a GeoB. So GeoB means the complete worldwide data. If you want to calculate the storage units, we can calculate within the representation is GeoB, and it will be like a 1024 BB. Okay, like this our storage units are increased from lowest to biggest. Okay, but most of the organization we can see, even the small size organization or medium scale or large scale organization or extra large organization, the minimally the data is starts from a TBs only. So the are based on the infrastructure size, the data increase from TB to petabyte, petabyte to exabyte, and so on. Okay, so I will try to give you one example now. What is the average storage growing level with real world examples? So this example I collected from the internet based on the survey. They given the one of the survey result, what is the average usage per year is, it's a 25 terabyte. Let's try to understand one by one. So normally common image modalities, like normally in our hospitals they may use a x-rays. X-ray means digital radiography. So this x-ray, now, typical resolution is 2048 by 2048. Average size per study, one X-ray size will be 30 MB file, and average study count duration per day they may take around 4 X-rays, and the total size is equivalent to 120 MB. So this units we are now familiar MB, and this same 120 MB it's per one day. Let's say if you calculate for 365 days, so 365 into 120 it's equivalent to 2.16 terabyte. That is only for X-ray files in a one hospital. And same way, if you consider as a compute tomography CT scan, so CT scan size also typical resolution 512 by 512, and average study is 700, and the size is 367 MB. So per year annual total is approximately 3.6 terabyte. Similarly for MRI scan, mammography and ultrasound, and even if you capture any of the video also, normally in the hospitals they may capture few images. These all the storage on average, this is the total sizes per day, and if they multiply with the annual 365 days, the sizes are equivalent to overall size will be 25 terabyte. This data is collected from a based on the storage calculator default values. It's not a manual calculation. Okay, the same way the multiple examples are available even if your organization also, if you compare your servers, normally most of the servers are divided into a three categories: test servers, development servers and production servers. Even the test servers data, if you have a test servers, 10 test servers, the 10 servers data if you calculate also it's equivalent to more than 10 TB of size, and development servers more than 30 TB. If you have a production servers around 60 production servers, the data will be more than 100 TB. So even if you want to store all your data, your production related data as well as test and development data, the normal local hard drives are not enough. We have to go for a either NAS storage or we have to go for a SAN storage. Even within the SAN storage, there will be a multiple protocols are available. Either you can use FCOE or you can use a fiber channel. Even to your infrastructure is looking for a, instead of a physical SAN, they want to looking for a virtual storage. Like they want to use a software defined storages. Like we can use virtual SAN, or we can use a Nutanix AOS storage, or you can use any of the other third party tools like Cumulo, Skeleton and so on. Okay, so these are all the options available, and I given one best example, the medical imaging, how the sizes are grows from day to monthly, monthly to yearly. So same applicable for all your organizations also. So with this example, it's we have some clear picture why our storage sizes are growing from smallest to biggest. Okay, so to store all your old data, definitely we require a multiple storage devices in our organization. So let's understand what are the types of storage now. So what are types of storage? So we have three types of storages: block storage, file storage and object storage. So why we have this many three types of storage is there is definitely there is a reason behind. Application need a certain type of storage. So block storage, file and object storage, and storage is consumed through protocol only. So those points we can discuss now. Let's understand the first point, storage type. So storage type, data stored in fixed size blocks in a fixed arrangement, ideal for enterprise applications and databases, and fully integrated with servers and a specific location on memory or disk. And file storage, normally the file servers, shared files and folders are stored in a file storage, and data stored as a files in hierarchy nested folders, ideally for active working documents. So fully managed network attached storage in short form NAS. So specific folder in fixed logical order. And object storage, data stored as objects in scalable buckets, ideal for unstructured big data, analytics and archiving. So for any application, store any type and any amount of data for any duration and retrieve it is often as needed. Okay, and flexible container size and no platform dependency. So that is importance of object storage. And let's understand the examples for a block storage. Normally the pen drive, hard disk, and the self solid state drive, flash drives, and Amazon EC2 instance store, and Amazon EBS elastic block store. These are all the examples for block storage. When comes to the file storage examples, we usually in our organization, every organization have a shared file servers. So either you can use a normal NAS file server or you can use a DFS distributed file system, and unstructured mainly for unstructured data, and as well as Amazon EFS also one of the example, elastic file system. And when comes to the object storage example, we have a Dropbox and Google Drive, we have a Amazon S3, and S3 means simple storage service, and Amazon Glacier, this is also used for a archival storage. If you have a past 6 months and past 1 year data, we no need to save in a block storage, we can better to store it in a object storage. The main reason is block storage cost is very high when compared to the object storage. So those kind of archival data we can store it in a Amazon Glacier. Not only Amazon Glacier, this type of services are provided by other public cloud services like Azure also providing, even the Google also providing. And another example of software defined storage or object storage is Scality. Even Scality also introduced the mainly two products, a Scality Ring and a Scality Ateska. And then in general, if you want to your organization data is minimal, if you have a 50 terabytes of your production data, better to go with a, if you want to start small, we can go with a Scality Ateska tool. And suppose if your organization data is starts from minimally 200 TB of size, so that scenario, instead of Scality Ateska, you can go for a Scality Ring. Okay, so Scality also providing a object storage capabilities. Okay, and now comes to the protocol. Even within the block storage, we have a multiple protocols. Here are the few examples. We can use fiber channel over Ethernet, SCSI, Internet SCSI, and SATA, simple advanced technology attachment. And even the file storage, we can use access the file storage through TCP/IP protocol and net NFS, network file share, and server messaging block SMB protocol. And we can also access using CIFS, common internet file system. And similarly, object storage also we can use TCP/IP, HTTP, that means using internet. We can also access HTTP protocol and REST protocol and SOAP. And REST full form is representative state transfer, and SOAP means simple object access protocol. And same way, Scality also use a similar type of protocol, SOFS, Scality object file system. And even the other third party tools also have a different type of protocols. Okay, with interest of our time, I'm just giving a brief overview, and even if you're interested in additional concepts, I will cover in the later sessions. And another thing is, see, this is the example icon for block storage. This is the icon. And file storage means normally in one folder, it's a shared among the users. It consists of multiple files and folders. And object storage, generally the example is buckets. So AWS buckets are looks like this. It's completely unstructured items, unstructured data is stored in the S3 buckets. And for the long-term services, like if you want to archive storage, either Amazon Glacier or Scality, you can use a long term. This is the icons to represent the long term services. Okay, and even the icons I given in the top also. So how the object storage mainly for cloud and Dropbox, this is the icon. Okay, now what are the storage interfaces among block, file, and object storages? So the what is the main interfaces to access the storages is To access the block storage, we need a operating system. You can use Windows operating system, Linux operating system, Solaris, or any of the other third-party operating systems. And another method of accessing interface is direct attached storage, storage area network. And when comes to the user file storage, we can use user interfaces or command line user interface or graphical user interface. And for object storage, we can access through the API application program interface. And performance wise, normally the block storage performance is high when compared to the file and object, and the file storage is medium and object storage is low. But nowadays some of the organization, they are also giving a compared to file storage, object storage also giving a better performance, okay, equivalent to the file storage performance, not only for the buckets, even for a long term services, storage services. And storage location, even for block storage, you can use the block storage in within the on-premises storage, and we can also use it for a private cloud. This is a representation for private cloud icon, and you can not only private cloud, you can also store your block storage in a public level, public cloud. So, and now even you can use for a hybrid cloud perspective. That means the block storage, the main storage location is not only for on-premises, private, public, and and hybrid cloud. We can also use for a multi-cloud purposes or cross-cloud purposes. And the same way, file storage also applicable for all the environments. You can use for a data center, on-premises, private, public, hybrid, and also multi-cloud. And same applicable for object storage as well. Okay, we can use for a workload. You can store the data in object storage in all the environments. Okay, now another point is, what are the storage scalability options among block, file, and object storage? So scalability options means how we can do the, how frequently we can do scale up or scale down. That options we can observe now. So if you want to do a scalability, that means capacity to be changed in size. Either it is a scale up or scale down, or you can use for a auto scaling. But generally block storage, once you fix the storage, that can be the block storage is low, and the file storage, the storage is high. And object storage, this is a high. That means it's a free to increase the size, and same applicable for file storage. And the cost wise, normally the block storage cost is expensive, and the file storage size is also high, and the object storage compared to file and block storage, the pricing is bit low because it's available as a service only. Object storage is available as a consumption based service model or pay as you go model. Okay, and amount of data, generally when we prefer the block storage is, if your storage is approximately less than 500 terabytes, you can go for a block storage. And if your storage is less than 100 or 100 to 50, between 100 to 500 terabytes, for scale out expansion of network attached storage, you can go for a file storage. And for when comes to the object storage, if your organization old archival data, and if you want to store for long term purposes, you can, if the data is more than 500 TB, better to go for a object storage. And object storage in many cases, petabytes of data is stored. Okay, and now another point is, what are the storage use cases among block, file, and object storage? The main use cases we can discuss now. So as we know, we have three types: block, file, and object storage. The proximity, that means accessibility. If we want to access our block storage, the dedicated network fiber channel is 10 Gbps, and the file storage is LAN 10 GB, and the object storage we can accessibility through internet connection. Okay, and the types of update, so supports in place updates. Even if you want to do any of the storage level updates, we can perform. And same thing we can update apply on a file storage. And also the no in place update support is updates in generally in object storage level. Updates is nothing but a creating a new object versions only. Okay, the versions can be increased. And normally even in the block storage, if you want to update without any interruption, we can perform. Same applicable for all three scenarios. And now it's the time to understand the use cases. So block storage main use case is low latency and best for structured data and unstructured data. And disks for virtual machines, VMFS volumes, virtual machine file system volumes, share read-only data across virtual machines. Not only virtual machines nowadays, even the virtual machines next level is started like containerization. All your containerization applications also you can store in the block storage. And storage for databases and frequently changing data. These are all the common use cases when it comes to block storage. And file storage perspective, it's a good performance and file sharing the data, media processing, and application migrations, and web content management, and unstructured data and file backups. We can prefer to choose file storage. And object storage mainly for easy scaling with no limits. So even if you want to storage more than 500 TB, easy to use object storage, and accessible across LAN and WAN wide area network, and stream mainly for streaming videos, images and documents, and backups and regular archives. And archive means long-term data, and also the websites and configuration data. And even if your organization, instead of maintaining a disaster recovery site, the disaster recovery site data also we can keep it in a object storage. And example is Skeletti Ring or Skeletti Artisca. And relative static file data and as cloud storage. Even cloud storages, we can use Amazon S3 or Amazon Glacier, any of the depends on our customer requirements. Okay, so and the icon wise, we know the storage location places and updates. It's applicable for all the locations. You can do it for a on-premises, private, public, and hybrid. The same scenario applicable for object storage also. Okay. Suppose if you are interested to learn some other in detail concepts of storages, I already covered in our previous session. So let me show you in our YouTube channel. So when you visit our YouTube channel, Gnan Cloud Garage, so there will be a multiple tabs are available for all the sections. Suppose if you look for if you're looking for secondary storage solutions like a modern data protection solution, I covered few solutions here. And also there are specific to the storage solutions. If you see the VMware vSphere concepts, if you see under the VMware vSphere concepts, let me go back and go to the playlist. If you see the playlist one, under the playlist, or let me show you from the director tab. Sorry. Around 10 plus videos I already prepared for the storage. If you see the section from 15th, see the 15th onwards, these videos are mainly for storage only. I'm trying to show you the better view. Yeah, maybe if we click here, yeah, we'll see the better view. Suppose if I see starting from the 15th video, I covered the few vSphere storage concepts and also NFS storage configuration, iSCSI storage configuration, and FC and FCOE and vSAN virtual volumes. If you're interested, you can just watch these videos. It's provided with the home lab. Okay, and some data protection solutions also I provided recently. Modern data protection solutions, Zeto few options I've shown you, and some other concepts are in a modern data protection solutions. So you can go through this if you are really interested to learn some other storage concepts, and even some of the other concepts like software defined storage and all, I will cover in the later sessions. Okay, so back to the slide. So that's it for today. If you're watching this video first time, please subscribe. And if you're already subscribed, thanks for your support and encouragement. Bye for now.